Hello, I'm Professor T.S. Sadhav from Fulton Education Society's College of Engineering, Fulton, from Computer Department. Today, I'm going to explain experiment number 1 from Digital Electronics, which is study of gates that are AND or NOT, NAND, NOR, XOR and XNOR. Hello everyone, I am Professor T.S. Sadhav from Computer Department of College of Engineering, Fulton. Today I am going to explain the experiment number 1 from Digital Electronics, that is study of logic gates AND or NOT, NAND, NOR, XOR and XNOR. This is the introduction of logic gates. The logic gates are nothing but the switches or the switches in and the basic building block of digital circuits. These are the electronic circuits which has one or more than one inputs with one output. The logic gate can also be defined as the digital circuit that can allow a signal, that is electrical current, to pass or stop. They uses the binary signal, that is 0 and 1, to process the circuit. These binary signals are nothing but the voltage levels, that is 0 means 0 volt and 1 is the 5 volt. Now we will learn the logic gates using the symbol of the logic gate, the Boolean expression and the truth table. The Boolean expressions are the expressions that evaluate a condition and results the Boolean value, that is true or false. That means the Boolean expression shows either the given condition is true or false using the binary values 0 and 1, where the 1 represent true and 0 represent the false. And also we will summarize all the possible outcomes for all possible combinations of the input of the logic gate using truth table. These are the types of logic gates. Basically, the logic gates are divided in three categories. That is, first one is basic logic gates. Under basic logic gates, AND, OR and NOT gates are included, while in universal logic gates, NAND and NOR gates are included. The XOR and XNOR gates are considered under the special logic gate category. The universal logic gates are the logic gates which are used to construct complex digital logic circuits. So NAND and NOR are also called as the universal logic gates. This is the first logic gate, that is AND gate. The symbol of AND gate looks like a D. I have shown here the two input AND gate, that is A and B are the inputs to the AND gate, and Y is the output of this AND gate. The Boolean expression is shown, can be written as Y is equal to A dot B. Here dot means the A and B. Here logic multiplication operation is performed in AND gate. The truth table shows the possible outcomes of all the possible combinations of the input data. That is, here I have used two inputs, so there are total possible outcomes are 4, and the NAND gate gives output 1 only for this last A and B possibility, that is A is equal to 1 and B is equal to 1. Then and then only the output of AND gate is 1. This is the second basic logic gate, that is OR gate. The symbol of OR gate is shown in this diagram. It is the two input OR gate. A and B are the inputs of this OR gate and Y is the output. The Boolean expression for OR gate can be drawn as Y is equal to A plus B. Here A plus symbol indicate the OR operation. The truth table shows that the OR gate gives output 0 only for both the inputs 0. That is, when and only when the output is 0, only when both the inputs are 0. For the other all the possibilities, the output of OR gate is 1. This is a NOR gate. We can also call it as an inverter gate. The symbol of this NOT gate looks like a triangle with a bubble. This is the gate which has only one input and one output. It does not have more than one inputs. Here A is the input and Y is the output of this NOT gate. It is called as an inverter because it inverts the input signal and gives the output. That means, as shown in this truth table, if input is 1, then the output is 0, that is the input is inverted, and when the input is 0 then the output is 1. That means the input signals are inverted at the NOT gate. This is a first universal logic gate, which is NOT gate, NAND gate. The symbol of NAND gate is shown in this diagram. The NAND gate is constructed using AND gate and NOT gate. So the the output of the NAND gate is the complement of AND gate. That is, when inputs are 1 1, then and then only the output is 0. Otherwise, for all the other cases, the output of the NAND gate is 1. That means the NAND gate gives output 0 only when both the inputs to the NAND gate are 1. This is the second universal logic gate, that is NOR gate. The symbol is shown in this figure. This is two input NOR gate, that is A and B are the inputs and Y is the output. The NOR gate is the complement of the OR gate. That means NOR gate gives output which is complement of the OR gate's output. The output is summarized in this truth table. That means it gives output 1 only and only 1 when both the inputs are 0, and for the rest of the possibilities the output is 0. This is the XOR gate. I have shown here the symbol of the XOR gate. This is two input XOR gate with one output. The Boolean expression of XOR gate can be shown as Y is equal to A XOR B. The XOR gate gives output 1 only when both the inputs are different. That means when the inputs are same, that is 0 0 or 1 1, it gives the output 0, and for other two cases it gives output 1. This is the second special logic gate, that is XNOR gate. The symbol of XNOR gate is shown in figure. It is the Boolean expression for the XNOR gate can be shown as A XNOR B, which is the complement of the XOR gate. That means it gives the output 1 only when inputs are same. That is, when the input is 0 0, the output is 1, and when input is 1 1, then the output is 1. For the other two cases, the output of the XNOR gate is 0. So lastly, let's summarize how many gates we have studied. First one is the AND gate, second one OR gate and NOT gate. These are the basic logic gates. These are used to construct all the other logic gates. The output of AND gate is 1 only when both the inputs are 1. For OR gate, the output of OR gate is 0 only when both the inputs are 0. For NOT gate, it is also called as an inverter because it inverts the output signal for the input. That means when output is 1, then when input is 1, then output is 0, and when input is 0, then output is 1. NAND gate and NOR gate are the universal logic gates. NAND gate is the complement out of the AND gate, and NOR gate is the complement of the OR gate. So it shows the complementary output of the AND gate, and NOR gate shows the complement of output of the OR gate. XOR and XNOR gates are the special logic gates which shows that XOR gate gives output 1 only for the different inputs, and XNOR gate gives output 1 only for the same inputs. Here buffer is also shown. Buffer gives the same output as the input. That means When input is 0, then output is 0. When input is 1 and output is 1. And as I have discussed earlier, NOT gate inverts the input, and this is all about the logic gates. Thank you all.